Welcome to Mrs. Bays' 6th grade math video lesson. This is the third video in the series on factors and multiples. In this lesson, we're going to focus on word problems with greatest common factor and least common multiple. Please do not use a calculator, but you can use your multiplication chart and hundreds chart. Let's begin by looking at our vocabulary. First is greatest common factor. So let's look at each word. Greatest, we need to think about it being the biggest or the largest. Common means we're going to find a number in both. Meaning both trees or both cakes or both lists. And factor, remember those are numbers that we multiply together. To get a product. Now let's look at least common multiple. Well, again, let's break it down here. Least means smallest. Common, again, is where you find a number in both. Both, meaning in both diagrams for the trees or both cakes or both lists. And the multiple, those are numbers that increase by the same amount. So what I mean by that is, let's say we take 3 and the multiples of 3 would be 3 and they keep increasing by 3, or multiplying like 1 times 3 and 2 times 3 is 6 and 3 times 3 is 9 and 3 times 4 is 12. So they keep increasing by 3s. Those are multiples. And now let's think about labeling. Whenever you have word problems, you must look for the label. That is usually one word, but it can be more than one word. So it's one word or 2 words, and at the very most it would be a very short phrase. And these would be words, or even we can use symbols. And so if you remember in earlier videos, we said that a symbol could be like when we were referring to money, it could be the $sign. So those are labels that we might be looking for. Let's begin by looking at some signal words or signal phrases. So for the greatest common factor, a signal word, the most common signal word, of course, is the word greatest. You might even see greatest number, greatest part, you also may see the word maximum. Again, you might see maximum part, maximum number. And now let's think about least common multiple. Well, least means smallest. So you might have the smallest number. Or minimum. or even minimum number. And the last one is every something. And usually in this blank there's a number, like every 4th, every 10th, every 100th. Sometimes you'll even see it written for every. And then the next is a number, every 1st, 10th, and so on. So let's think about these signal words and phrases and look at a few examples. Let's look at the first. Wayne's Bath Shop sells bars of soap in boxes of 4 bars and bottles of soap in boxes of 8 bottles. An employee is surprised to discover that the shop sold the same number of bars and bottles last week. What is the smallest number of each type of soap that the shop could have sold? All right, let's go back and look for some things that we need to be able to solve this problem. First I see 4, and that's 4 bars. And then we see 8 bottles. So it looks like we definitely need those 2 numbers, 4 and 8. Now let's see if we can find a key word or key phrase or signal phrase that will let us know if we need least common multiple or greatest common factor. So let's go to the question. What is the smallest number of each type of soap that the shop could have sold? Here it is, smallest number. That tells us what we're going to do. Smallest number. So if we look back at the chart that we made, smallest number, we need to find the least common multiple. So that's what we're going to find, is least common multiple. And our keyword here was smallest, or smallest number is the phrase. On this one, I think I'm going to use the tree diagram. So that would be 4 and 8. We'll put in my branches. 4 is an even number, so the smallest prime number for an even number is 2. So 2 times what is 4? Well, that's 2. And we've learned that 2 is a prime number, so that means I'm going to keep both of those. And now let's go to 8. 8's even. So the smallest prime number for an even number is 2. And 2 times what is 8? Well, that's 4. So I know 2's prime. 4 isn't. So that means I need to either break it down or show the branches. 4 is an even number, so its smallest prime number is 2. And 2 times what is 4? That's a 2. So we know that those are primes. We will go ahead and circle those because we need those. Now let's find the least common multiple. I'll put it right here. So we go to the first number, and in this tree we have 2 2's. Well, for least common multiple, we need both of those. So I'm going to go ahead and write those down. 2 times 2. So I'm going to keep this one and keep this one. Now I look to the second tree, and I see a 2. But I already have 1 2, so I don't need this one. And here's a 2, but if I look in the first tree, I had 2 2's. I already have 2 2's as in my part of my answer, so I don't need that one. But then I look and I see I have a third 2. But in the first tree, I only had 2 2's, so that means I need this one. So times 2. We'll keep that one. And now we multiply. 2 times 2 is 4. And 4 times 2 is 8. So our answer is 8. 8 what? Because it's a word problem and we need to label. So now we need to think about, well, how do I find a label in this kind of a problem? So to do that, I recommend that you look at the question again and ask yourself this question. And I think I'm going to go ahead and write it down just to help us out. The smallest number of what? Whatever goes in that blank, that makes good sense, that will be our label. So thinking about this word problem, think about what they're talking about. Bars and bottles of soap. What is the smallest number of what? Is it of each? Smallest number of type? Smallest number of? Or is it smallest number of soap? Well, the answer is soap. So now let's go back up here to what our answer is. Our answer is 8. 8 what? Well, if I put soap, 8 soap, that sounds ridiculous. 8 is more than 1, so we need to make soap plural, so we're just going to add an S. That would be 8 soaps. Let's look at a second example. Rosa picked 18 tulips and 20 daffodils. She divided the flowers into groups so that the same number of tulips and daffodils were in each bouquet. What is the greatest number of bouquets she could have made? Well, let's go back and look for our numbers first, see what kind of numbers we're going to be using. So Rosa picked 18 tulips. So 18 what? Tulips. And 20 what? Daffodils. So those are the flowers. Notice we're going to put them in the same, they're going to be divided into the same number of bouquets. And then if we want to go to find out if we're going to do least common multiple or greatest common factor, we go to the question. What is the greatest number of bouquets she could have made? Here we go. Greatest number. That tells us what we're going to do here. That is greatest common factor. So now let's write down 18 and 20. And again, I think I'm going to do the tree diagram. Remember, you could also do cake or lists if you prefer. 18 is an even number, so the smallest prime for an even number is 2. 2 times what is 18? Well, that's 9. 2 is prime. 9 is not, so that means we need to show our two branches. 9 is an odd number, so the smallest prime odd number is 3. 3 times what is 9? Well, that's 3. And now we know that those 3's are prime. Now let's go to 20. 20 is an even number. So the smallest even prime number is 2. And 2 times what is 20? Well, that's 10. 2 is prime. 10 is not. 10 is even though, so we're going to use our smallest even prime number. That's 2. And 2 times what is 10? Well, that's 5. We know that 2 is prime, so is 5 prime. So now let's find the greatest common factor. So here's where we compare both trees. So I'm going to start here. 18 has a 2, 20 has a 2. So we definitely need those. Those match. So I'm going to circle both and write down 1, 2. Then I have a 3, but over here I don't have a 3. I have a second 3 in the first tree, but I still don't have a 3. So can I use these 3's if there's not another common 3 over here? The answer is no. So I'm going to mark those out. So then I go over here and I have a 2. And I said, oh, I have a 2 here, but I already used this 2 because I matched it with this 2. These 2 match, and I wrote it down. So do I have another 2 here I can use? No. So I mark it out. Here's a 5. Well, again, I need a 5 in this tree if I want to use a 5. Well, I don't have a 5 in this tree, so that means I can't use that one. So all I have is 2. So now I need to think about, well, what would the label be? So again, let's look at the question, and we're going to be thinking greatest number of what? So let's go to the question. The greatest number of what? Bouquets. That means bouquets is our label. So we have 2 bouquets. Let's look at one more example. Number 3. Every 4th visitor to a museum gets a free bumper sticker. Every 10th visitor to that museum gets a free keychain. Which visitor each day will be the first one to get both the bumper sticker and the keychain? Well, let's go looking for some numbers first. Well, I don't see any numbers that are written in number form. So I'm going to have to look at numbers written as words. So here's 4th visitor. And let's see, every 10th visitor. So here's 10th visitor. And we're trying to figure out, well, which visitor is going to get both a bumper sticker and a keychain. So if I go back to that table that we started with, and I notice that whenever I see every or for every, we're looking for the least common multiple. So that means I'm going to look for the least common multiple. So this time I'm going to do a list instead of the tree diagram or the cake method, because we're thinking about, we're going to a museum and it's the 4th person that goes in, and then the next 4th person that goes in, and the next 4th person to go in. So I'm going to write these numbers vertically. So we have the 4th person, the 4th visitor, and the 10th visitor. What's the smallest multiple of 4? Well, that's 4. And now let's write the multiples of 4. So that would be 4, 8, 12, 16, 20, 24, 28, and I'm going to stop there for now. Now let's do 10, multiples of 10. The smallest is 10, and that would be 10, 20, 30, 40, 50. Well, let's stop there. Least common multiple. That means we want the smallest number that is in both columns. So I'm looking. Here's 4, here's 8, here's 12, here's 10, so that's not going to work. Here's 16, but look, here's a 20 and 20. So the least common multiple then is going to be 20. But now we need to figure out, well, what's the label? Remember, it's a word problem, so we have to figure out the label. Well, in the last 2 examples I've showed you, I was asking the question, greatest number of what? But if we look at this question, we don't have those words. Which visitor each day will be the first one to get both the bumper sticker and the keychain? So in this case, we're going to look at which what. And I'm going to write that down. Which what? So let's go up to the question, which what visitor? So it is 20 visitor. Now, hold on a second. That doesn't make any sense. Does that mean 20 visitors? 20 visitors are going to get both a bumper sticker and a keychain? No, that's not what the question's asking. It wants to know which one. So in this case, we might want to say it is the 20th. So I'm just going to add a TH there. It's the 20th visitor that goes to the museum that's going to get both the bumper sticker and the keychain. Now let's look at practice that I'd like for you to do. I want you to go to iExcel, 6th grade, E.12, and you should see the words GCF and LCM word problems. Please work to get at least 80% to get full credit, and if you work a little more to get 100%, you will get a bonus point. Good luck.